Alrighty, in this section, we are going to be graphing exponential functions. So these are some of the options of what your exponential functions could look like. And the one thing that's really important about this type of graph is what's called an asymptote. So all of these graphs look like they're getting really close to a certain spot, but they're not actually touching that number. So they look like they kind of are, but they really are not. So there is like an invisible fence on these graphs of what these graphs are getting really close to, but they're never actually touching. I like to think about it as an invisible fence. You can get really close to it, but you don't actually want to touch that invisible fence. And that's what's called an asymptote. So that is a line that a graph gets very close to, but does not touch. Now, all of these asymptotes are going to be written in y equals and then some number, just like a Hoy equation would be written back when we were writing horizontal and vertical line equations. So the first one we're going to graph is y equals 3 to the x power. So the first thing I want you to go and do is go to your calculator and type in the y equals 3 to the x power. So once you do that, you're going to go to second graph and you're going to find as many points as you possibly can to graph. And it looks like I can plot 2, 9, 1, 3, 0, 1, and then it starts to become decimal. So negative 1, 0.333, negative 2, 0.111. And if you notice on your table, these are getting really small decimals. But we are never actually getting to the number of 0. So I'm getting really close to that 0, but I'm never actually touching it, which means I have an asymptote right here along my x-axis. Now, that's never going to always be on the x-axis. That line may move up and down, just depending on what kind of graph you have. So first off, from domain and range. So domain, we go from left to right with a vertical line. So the very first thing that I touch is an arrow, which means I'm going from negative infinity. And the last thing I touch is another arrow, so I'm going to positive infinity. Remember, when we use infinities, we use parentheses. Okay, for range, we're going to go from bottom to top. So the first thing I hit is that asymptote, that green dashed line. So that green dashed line is on 0. And we just talked about we are not actually touching that 0. We're getting really close to it, but we're not actually touching it. So we are going to use a parenthesis to show we're not really touching 0. Then if we keep going, the very last thing that we touch is an arrow again, meaning we're going to positive infinity. Then if you look at our graph, our y-intercept was at 0, 1. Make sure you're writing that as a point. Our x-intercept, we are never touching that x-axis. So we're going to say we don't have any x-intercepts. We have none. Our asymptote was at y equals, and the number we were getting very close to was 0, but we never actually touched. Okay, let's try another example. So take this in your calculator and type in 1/2 to the x power. Make sure you put that 1/2 in parentheses. So I'm going to go to my table, and it looks like I can plot -3, +8, -2, +4, -1, +2, 0, 1, and then from there it's going to fractions. So 1 and a 0.5, 2 and a 0.25. So it's getting very close to my x-axis again, but those decimals never actually touch 0. So it looks like we have an asymptote again on our x-axis. This is not always going to be the case. So our domain, the first thing we touch is an arrow, so negative infinity, and the last thing we touch is an arrow, so to positive infinity. For range, we're starting at the bottom. The very first thing we touch is that asymptote, which is at 0, but we are not touching, so we're going to use a parentheses. The very last thing we touch is an arrow again, so we're going to positive infinity. Our y-intercept again was at 0, 1. Make sure you write it as a point, an ordered pair. The x-intercept, it looks like we were never touching that x-axis, so we would say none. Then our asymptote, we have to say it as y equals, because it's a horizontal line. And we were getting really, really close to 0, but we were never touching it, so that is where our asymptote is at. Okay, looking at the next one, let's plot this in our calculator. Y equals 3 times 4 to the x power. If we go to our table, it looks like I can plot 0, 3. 112, I'm going to fake it a little bit, put it up a little high, and then after that, it looks like I got decimals. So negative 1, 0.75. We're getting really close to that x-axis. So we're never actually touching it, but we're getting really, really close to it. So that means our asymptote is again on that x-axis. That x-axis could move up and down as well. So our domain, first thing we touch is an arrow. Last thing we touch is also an arrow, so we're going from negative infinity to positive infinity. Then looking at range, the first thing we touch is that asymptote, so that was at 0, but we weren't actually touching it, so we're going to use a parentheses. And then the last thing we touch is an arrow, so we're going to positive infinity. On the y-intercept, it looks like we were crossing at 0, positive 3. For the x-intercept, we were never touching that x-axis, so I'm going to say none. Now, this will not always be none, but on this one, it is. Okay, and then our asymptote, again, we have to say y equals, and that number we were getting really, really close to, but not touching, was 0. All right, next one, we want to graph in our calculator. Y equals, we have a negative 2 with a 1/3 to the x power. And then you're going to go to your table, and it looks like we can plot 0, negative 2, negative 1, negative 6. And then the other ones I can plot are all decimals, so 1, negative 0.667, 2, negative 0.222. So we're getting really close to that x-axis again, but our graph is down below, which looks like it was because of that negative we put out front. So our asymptote, we were getting really, really close to that x-axis again, but from the other direction. So the very first thing that we touch for domain is an arrow. So we're going from negative infinity, and the last thing we touch is an arrow, so we're going to positive infinity. After that, our range, the very first thing we touch down below is an arrow, so we're going from negative infinity, and the last thing we touch is our asymptote, which was at 0, and we weren't actually touching it, so we're going to use that parentheses. Then it looks like we have a y-intercept at 0, negative 2. Our x-intercept, we don't have any, we would say none. And then our asymptote was y equals, and we were getting very, very close to 0, but never touching. Okay, let's look at some patterns. So on these ones, we're going to look for something that, how we're getting from each number to the next. So what is the pattern? So 4 to 24 to 144 to 864, so on. It looks like this is multiplying by 6. So our initial amount that we began with was positive 4. And this says constant ratio, but I like to call it your multiplier. And you'll see why in a minute. Our multiplier was 6. We were multiplying by 6. So that makes our two parts to our equation. 4 times 6, and then to the x power. Make sure you do not forget that tiny little x. Okay, let's look at this one. We have 9 to 27 to 81. It looks like it is multiplying by 3. So each time we're multiplying by 3. Our initial amount was 9, and that means that our multiplier down here, our constant ratio, was positive 3. So our equation is 9 times that 3 to the x power. Please do not forget that x. All right, next one, it looks like we're going from 39 to 13 to 13 over 3, which is going down. So it looks like we are dividing by 3. Now, we talked about that this down here is our multiplier. So we have to write what this is multiplying by. And we just said that it was dividing by 3. So a way that you could say this dividing by 3 is the same thing as multiplying by 1 over 3. So that means our initial amount was 39 and our multiplier was 1/3. So that makes our equation 39 times a 1/3 to the x power. All right, last example, we're going from 350 to 50 to 50 over 7. It looks like we are dividing by 7, which we just talked about. We cannot write this as division. So this is the same thing as multiplying by 1 over 7. So that means that our initial amount was 350 and our multiplier was 1 over 7, making our equation 350 times a 1/7 to the x power.